here's what I want to point out to you. This method of going through and everything, it's nice, it helps you understand what is going on, but there's a problem, namely, boy, does it take a long time.
Yeah,
and you guys know how famously lazy mathematicians are. We're always trying to do the minimum amount of work. Now you have a look at this. Clearly there are patterns involved. There are patterns everywhere. So how can we take advantage of it? Here's what I want to point out to you. Have a look at this middle column in here. You have a look at it. Okay? Now, is there a way I could just go through this middle column and just go from one number to the next and not worry about doing all of this extra stuff as a separate set of processes? Here's the way I'm going to do it. When you think about how we got from the first year to the second year, right? We started with this amount. We calculated the interest, which was multiplied by 0.06, and then we added on the original amount. That's simple, right? So you add on one lot of this original amount. Now I can do both of those at once, right? We actually had a look at this back when we were doing earning money, right? Do you remember this? And it's like, oh, you want to work out your double time, your time and a half, blah, blah, blah. You put all your hours in together, and then you multiply by your hourly rate, okay? This is exactly the same pattern. Now, if you do this, you do 2,400 times, I can do it even quicker than that. I can just say that's 1.06, and your calculator is going to hand back to you 2,544 right away, okay? Now from there, this process here, this one here, that's just what takes me from one year to the next one. So if I took 2,544, multiplied it by 1.06, okay, it's going to give me that 2,696.64, etc. And one last time, if I go, and I actually want you to get your calculator out if you haven't put it away already, and just confirm for me. If you do this 2,696.64 and you multiply by 1.06, I'm expecting some rounding to happen because that's what I had to do here, right? If I remember my numbers right, it should hand you 2,858 and 43 blah blah blah, which rounds up to 44. So here's what I want to point out. 3 years, we did the same process 3 times. We multiplied by this, then we multiplied again, then we multiplied again. Right? So by taking simple interest repeatedly, that's what gives us this. The actual amount, right? The amount I ended on was the principal, what I started with, and then you do this multiplication 3 times, right? You multiply by 1 plus, what was that 0.06? What did that come from in the question? It was the rate, right? That we called that R from the original, right? And we did it 3 times, right? Why did it happen 3 times? And the answer is there were 3 years, right? It's whatever number of time periods you're looking at. Okay? Now this is the familiar compound interest formula that some of you guys met last year. It's got the same 3 pieces: principal, rate, and a number of time periods, but because we're doing something different mathematically, that's why it's arranged in a different way to this.
Is it just faster?
Okay? Well, it's faster because it shortcuts this whole process. It takes you straight from here to this final amount. But I will point out, it gives you something different from the simple interest formula, right? It gives you the total amount that you end with, this 2,000 whatever figure, whereas the simple interest formula is just telling you that 432 that you got at the end. That's just the interest, right? And you can check out 2,400 times 0.06 times 3, it'll give you 432 just like we had before, okay?